Hello and a very warm welcome to KognitoKey. This is where we unlock the secrets behind all the amazing technology that shapes our world. Have you ever just wondered how twisting that little knob on an old radio can somehow pull a specific song or a voice right out of thin air? I mean, it really does feel like magic, doesn't it? But the secret isn't magic. It's something called frequency. And believe me, creating a perfectly stable, tunable wave to carry that frequency, well, it wasn't always so easy. So today, we are going to dive deep into the absolutely brilliant device that finally tamed those waves, the Hartley Oscillator. We're going to look at the problem it solved, Hartley's super elegant solution, see how it actually works, that's the fun part, then figure out how we can control it, and finally why this invention, which is over 100 years old, still matters so much today. Okay, but before we can appreciate the solution, we really need to understand the problem. And back in the early days of electronics, let's just say oscillators were, well, they were a bit of a mess. Just imagine this. You're trying to listen to your favorite song, but the volume just keeps fading in and out, and you can barely even find the station in the first place. That's pretty much what early radio was like. The oscillators back then produced these really unstable fading waves. They were just uncontrollable and a total headache to tune. So the engineers knew they needed a much better way to create a stable, reliable signal. And that's where our hero comes into the picture. Right when they needed it most, an engineer came up with a design so clever, so elegant, that it's still at the very heart of so much of our technology today. So the year is 1915. An American engineer, his name was Ralph Hartley, he patents this truly groundbreaking invention. He had figured out how to create a self-tuning, incredibly stable oscillator, and it was about to change the course of electronics forever. So what is a Hartley oscillator? Well, at its core, it's an electronic circuit that generates a nice, smooth, continuous wave. But its secret ingredient? That's the tank circuit. See, instead of the usual setup, Hartley did something really clever. He used one capacitor with, get this, 2 inductors. And this simple, elegant little change was the absolute key to its success. All right, now for the really cool part. How does this thing actually work? You can think of it like a perfectly choreographed dance of energy moving between the different parts. Let's take a closer look. Okay, so it all starts the moment you switch it on. The capacitor charges up, right, storing energy like a tiny battery. Then, whoosh, it releases that energy into the inductors, which create a magnetic field. Now, when that field collapses, the energy flows right back into the capacitor. This back and forth, that is the oscillation. But just like giving someone a push on a swing, it would naturally slow down and stop. And that's where the amplifier comes in. It gives the circuit a tiny, perfectly timed push of energy on every single cycle, and that keeps the wave going strong and steady. So the big question is, how does the amplifier know exactly when to give that push? Well, it's all about timing. Engineers have a fancy word for it. They call it phase shift. But really, just go back to that swing analogy. You have to push at the exact right moment to make it go higher, right? It's the same thing here. The tank circuit and the amplifier work together to create a perfect 360-degree phase shift. And what that means is the push of energy is perfectly in sync with the wave, reinforcing it and just keeping it going and going and going. Okay, so we've got ourselves a nice, stable wave. That's great. But how do we actually change its frequency? To tune into different radio stations. Now that is the crucial question. Well, it's almost like baking a cake. The frequency is decided by a really simple recipe, and our main ingredients are the capacitor and the inductors. So if we change the amount of each ingredient, like say by turning the knob on a variable capacitor, we can actually change the flavor of our cake, or in this case, the frequency of our wave. And those 2 inductors, they have a really special relationship. You see, their magnetic fields actually interact with each other, and that creates something we call mutual inductance. The best way to think about it is teamwork. They work together like a single, more powerful unit, and this interaction, it's a super important part of Hartley's design. So why on earth are we still talking about a circuit from way back in 1915? It's simple, really, because it's a timeless design that just works, and it still gets the job done today. Now, of course, like any great design, it has its pros and cons. The big advantage is, well, it creates a wave with a really nice, constant amplitude. It's super easy to tune, the circuit itself is very simple, and you can even use a single coil that has a tap on it. But it's not perfect. It can sometimes create some unwanted distortions, we call them harmonics, and it's not really the best choice if you need to generate very low frequencies. So where do we actually see the Hartley oscillator in action? Well, its home, its sweet spot, is the world of radio. It is the perfect tool for generating those high-frequency signals that power our radios, which, hey, brings us right back to the question we started with. You know, the big takeaway here is that sometimes a simple, really elegant solution can literally change the world. The principles that Ralph Hartley perfected over 100 years ago, they are still fundamental to so much of our modern technology. It really makes you wonder, doesn't it? Where else are these foundational ideas hiding, right there in plain sight? Thank you so much for joining us on KognitoKey. If you enjoyed this little journey and unlocked a new piece of knowledge, please be sure to like, share, and subscribe to our channel for more. We'll see you next time.